how do we want to kind of do the next session is basically, I'm going to walk you through the 4 key areas or challenges that Mani talked about initially. We may not be able to kind of go through all of these, but like 4 core areas that we have divided this whole kind of overall cloud connectivity or cloud networking challenges. So we'll start with discover, build, secure, and observe. Now, when I talk about discover, it means that we, in the same context of the customer that we are talking about, primary questions that we typically hear is not about like connectivity and TGW and whatnot. They ask us, can you give me a snapshot of what is it that is running in my cloud? I mean, it's like 3 different clouds. I have to log into multiple consoles, go to like multiple regions and try to find out EC2 instances versus this application versus that application. Is there a way you can show all of that in a single control plane of sorts? So can you discover the assets for me? Then if you can build a catalog of existing connectivity patterns. So let's say a VPC running in EU West 2, how is it attached to through a VPC peering, or is it attached to a transit gateway? Does it have a private link connectivity established? Can you show me some of those from a brownfield perspective? I mean, greenfield, I understand I had to build some things with your platform, but can you give me a quick snapshot of what is it that I'm running in the cloud? And thirdly, can I easily show some of the things like quick route table information instead of logging into multiple consoles, just to make sure that the routing is all done correctly, what exactly the changes I will make using your platform, what will the changes that the platform will make using the dashboard. So itself, the asset discovery is a huge enough pain. And every time we interact with the customer, that's their first fundamental question. I do not know what actually I'm running in my cloud. So forget about connecting. First, show me what is that. So what we're going to do is that we'll take the lens of the same healthcare customer we have just discussed. Let's walk you through the process of how easy it is to see certain things, like, for example, your cloud regions, what resources you are running, how these things are attached, what are the different assets and different VPCs, different subnets, different applications. So the same control plane will discover all of that for you. And I'll ask Gaurav's help to kind of walk through the process of that.
Thanks, Faraz. So I think this discovery phase becomes very important when we are talking about brownfield environment, right? Where I already have existing networking constructs. You're asking me to build this fabric, attach my networks to it. I don't even know where to start. Especially with this, the case study that I'm talking about is I have roughly 100 Azure subscriptions, some 50 AWS accounts. I'm acquiring some GCP projects as well. At least help me start my journey with you guys. And that is where I'll go to our control plane. This is the control plane that every customer gets. It's a SaaS hosted. So and they use this control plane for configuring things. Now, before we get into the discovery, right? I think the important thing is just one thing I want to add is if you want Prosimo to discover certain things, this control plane will need access to the given cloud accounts as well. So we walk you. So there is a process called as cloud account onboarding. Now, every cloud provider has their best practices. If at all you want somebody to go and, let's say, a third-party API to go and access your control plane, do some automation, orchestration in it, here is the best practice. For example, AWS says, you know what, as long as you use IAM role and a strict policy, that is all we ask for. So the first step in order for Prosimo to go ahead and discover your network assets is a customer will come and onboard this cloud account onto their control plane tenant. And essentially that means is creating this Prosimo IAM role and policy that gives this control plane access and go and make an API calls to it, right? And there is no limit on how many cloud accounts you can onboard. You can onboard thousands of accounts. We have customers actually with 1,600 AWS accounts. There is another one with 900 AWS accounts. So, and this goes across clouds. You can onboard a GCP project. You can onboard AWS account. You can go for Azure subscriptions as well. And that is pretty much what you need in order to go ahead with the discovery. You don't need to deploy any Prosimo fabric. Nothing is required. As long as you've onboarded the accounts, let us give you the lay of the land. So all these accounts appear here. And the question that comes to my mind is, hey, where are my VPCs? What subnets am I running? Do I actually have some overlapping CIDRs that I need to be aware of? I'll give you an example. I click on this AWS account, Prosimo goes and finds that, okay, in all these regions, you have these VPCs. I'll take an example of US West 1. I have roughly 94 subnets in this particular region, and all of these subnets or VPCs are listed here. And inside this VPC, here are the two subnets. Now, you can do search, and it'll give you all the things that are there in this particular VPC. It gives you actually a mental map of, hey, here are my VPCs in this account. At least I can get started with onboarding these VPCs or attaching these VPCs to this Prosimo fabric, right? But the other challenge with the brownfield environment is that it's not just about VPC, right? They're using some sort of networking construct already. That could be, let's say that, hey, this VPC that you want to onboard, it's already attached to a transit gateway in AWS. How do you actually can you take that into consideration when you are asking me to attach this VPC to a fabric? And we absolutely do that. So in order to do that, you go to this page called Transit. And what this Transit does is it essentially walks you through the, it goes ahead, gives you, hey, where all you have the presence. Let's say I go into this, and this is where it has already discovered that in this particular region in AWS, let's say I only have 2 accounts right now, but if you have 100 accounts or 10 accounts, doesn't matter. These are the cloud native networking concepts. These are the transit gateways that are present. And these transit gateways are attached to these 3 VPCs. We didn't create these attachments. These already exist. So if I go to these 3 VPCs, these 3 VPCs exist in this region. You scroll down, it will actually show you that, hey, these 2 plus there is 1 more that is attached to a transit gateway. Now, how is and why is that important, right? Think about this guy. Let's say I already have a transit gateway. There is a VPC that is attached to it. Let's say that this is the least risky VPC for me to migrate to Prosimo and start turning the traffic on. Is Prosimo, first of all, capable of finding out where VPC is attached? That's number 1. Second, can you utilize this existing transit gateway and attachment so that I don't have to go and go and rip and replace anything? So you see, oh, we deployed Prosimo Edge. That is great. This transit gateway is not attached to this edge because there is no line. I have 2 other that are already attached. But in this case, it's not just about discovery now. The next thing is I actually want to build an underlay as well, right? Like let's say in this case, the transit gateway is not attached to Prosimo Edge. Do I have to go into AWS account, my Azure subscription, my GCP project, and build those underlays manually? That's one way to do it, because once you build, we'll ingest it. Or the other way could be you actually use Prosimo to build that underlay itself. So here is the transit gateway, here is the Prosimo. It gives you that, okay, this is what you want to do. You actually save this to deployment and deploy it under the hood. Prosimo will go into that AWS account, find this transit gateway, build the transit gateway attachment to the Prosimo Edge VPC. And at this point in time, your underlay is already built. So anything that is attached to this Prosimo fabric can talk to the VPC that is attached here, as long as there is a policy, right? So this actually it really helps us in brownfield environments where customers don't have to go and manually go into each AWS account, Azure subscription, GCP project, and figure out where are my VPC, how many transit gateways. The problem actually gets even bigger if I have to share these networking constructs across cloud accounts.
So you skimmed over this really quickly, but I think it's worth a double click. You just created that connection by clicking that asset and then clicking the Prosimo button and then save to deployment, and it connects it for you.
Right now, it's just showing that this is what you want to do. I can actually deploy it and it'll go and deploy it for you. Yes, I clicked on save to deployment. You go on to preview deployment. This is where it says, okay, this is what you are trying to configure. Hey, do you want to go ahead, review and deploy anything, right? And then you actually it goes, and it builds that underlay attachment for you.
An extra check that way, you just draw the line and then you can verify and say, yeah, this is what I want to push to my production.
So
And-
design, test, deploy. This the diagram was your intent sandboard, right? A sandbox. You can actually take that, run it against a change management team. Say, here are the changes that I'm proposing. These are the assets that are going to get, affected. Is that okay, right? And then it's saved. All you need to hit is. Now imagine how many screens you had to potentially crawl through to actually do this if you were doing this, cloud natively. And like I say, for most networking guys, right, it's exceptions are mostly the rule. Even if you had Terraform, you'd probably be working your way through like a dozen IP address exceptions, et cetera, to actually make this happen, right? So customers really love this, in terms of, there's a very visually intuitive way of sort of doing this. One of the requests that we've had is actually, can I take this intent and, turn it back into the IAC lifecycle, right? Can I use that as a Terraform state file, right? So we're also working on stuff like that.
Just curious, what are the formats? There's an export option every time you do a configuration change. What configuration language are you using to retain those? Do you store those like as point in time? Before we made this change, here was the state before, here's the state after. I know you've got some rollback capability and some other things as well. So I'd love to sort of see how you structure the codification of this asset.
The design decision we took was, and I'll keep the rules very simple, was one outstanding change set at a time per region, right? And you could work off, so if let's say Gaurav was making some changes and he had some design intent, he could save that. The moment you go into view deployment set, you get a view of what you're intending to change over the latest operational state, and you have to work off that, right? So there'll be one outstanding sort of change set per region. We did not set out to be a full-fledged sort of configuration management tool or configuration versioning tool, but as is the capability has been very well received by our customers, especially considering the complexity. Yeah.
So on the deployment side of it,
Mhm.
do we need to have the edges deployed at this point?
At this point, yes. For the discovery piece, you don't need edges. We'll discover everything, but if you want Prosimo to go and build the attachments.
Okay. And what services are running on the edges? I'm just asking because we're only deploying one. What would happen if one went down?
Great question, actually. So you only require one edge per region because we use Kubernetes that kind of, and things are already deployed in an auto-scaling group. So it scales out, scales in, multiple pods go down. If the only scenario that I can think of when, let's say, the edge is going to go completely down, either the entire AWS region itself is down, where there is a bigger problem that my applications and VPCs also are down, or there is, let's say, some EKS services down, right, because of which my cluster is down. Now, the design decision is, hey, I'm thinking about the disaster recovery, and I think the question that comes is, the good terms like RTO and RPO, I can definitely reduce it and I can have probably another edge, but at what cost, right? If 99% of the times my edge is always going to be up and running, that for 1% of the time that there is a chance that the whole AWS region goes down, Prosimo has a better way to recover it. So what you can do is you can deploy, there is another third component that for some special cases we reserve where you can go and deploy these Prosimo connectors in their VPCs that are super critical, and they will dial out to the nearest edge in a different region. So your networks are not losing access to any other service. But like deploying another edge is an easy thing, but I think, again, go by the cost optimization thing. If that other cluster is always going to be up and running, it incurs cost as well. So the balance is always, what is my RTO and RPO target? And based on that, do I want edge cluster to be always up and running, or do I use what Prosimo has to offer where the VPC can be connected to a different edge? Great question.
So to answer, so we have covered some of this architectural components in the last one, but just to give you a quick answer, it's not just the Kubernetes cluster. So it creates its own VPC. So when we onboard the cloud network, when we deploy an edge, it onboards or brings up its own VPC or a VNet. Then it kind of use certain resources like NAT gateways or load balancers, or those kind of cloud native components, if you will. So this whole thing that is housing this fabric, we call it edge. But edge is a kind of collection of multiple components. The primary component is always the EKS or the Kubernetes cluster.
Okay.
And these deployments that are being done from this SaaS control plane, are they using those same connections that you mentioned for setting up the discovery?
Yes.
So the access control that has needs to have relevant deployment or write access in the target accounts to
Correct.
deploy. Yeah. Okay.
So when we deploy the policy, like when we're onboarding the account, the policy contains what can this control plane do in that particular account.
Got it. Yep.
So should I see the edge as a management plane or should I see it as a transit?
You should see it as a data plane /
As a
transit.
data plane. So excuse my ignorance, like I've never used Kubernetes like as a something for the transit.
Mhm.
So are there any implications on a throughput and stuff like that? Like, what if I'm going to want to migrate stuff in between? Like, is this something you have tested? Maybe it's not an issue. I don't know. Like, I've never used it.
We have not seen this issue. On the contrary, I think about this. Like I think Mani talked about a typical architecture where you put routers and you build IPsec tunnels. At any given point in time, you are encrypting traffic, decrypting traffic. That actually adds a lot of time in terms of round trip and latency. In our case, the way you're attaching these networks to the fabric itself is using cloud native underlays, transit gateways, peering. So, and when the traffic comes to the edge, we are not getting any overhead because we don't have to do that encryption, decryption anymore, right? So from that point of view, we get the throughput. Let's say a transit gateway attachment in AWS can do 100 gigs. We can do nearline rate. And same goes in terms of latency as well.
Okay.
There is some hit, of course, for processing because we have to make a routing decision to go wherever the destination is, but not something.
Yeah, what we've seen is like, it's not really a throughput discussion, it's more about you're adding a hop in between. So from a science perspective, of course, you're adding some sort of latency in there. But what we have seen is that as long as the underlay itself, like it could be a TGW, it could be anything, as long as that can support whatever, like per attachment, 50 gig or 100 gig, we do not have a throughput block from our side. So the fabric or the edge itself is auto scalable. So if it sees more number of concurrent sessions, can automatically scale up number of pods, number of nodes required to kind of absorb that traffic. And when the load goes away, let's say on Friday, 5 p.m., there's not many application happening, you're not doing any data transfer to S3 buckets or anything, the edge has the capability to shrink itself.
Oh, okay, that's
So you're
good.
not
Yeah.
constantly adding this like unnecessarily compute power when it's not needed.
That's like sort of like where I was heading, right? Like, if you are deploying all this fabric, like that's sort of like defined for a certain throughput.
Yeah.
So what if I don't need that many? Okay, that's good. That's good.
So
So
Elastic
wasting
is-
Elasticity, yeah.
When you guys actually effectively scale to zero, right? Well, that's one of the things that nobody's able to.
Yeah, we will not
It's
scale
rare
to
that we.
zero. We definitely want that fabric there.
No,
Yeah,
we-
but it's like there's very limited resources needed behind.
Yeah,
in order
less
to
than
do
1
the
gig
first layer.
throughput, for example, for the entire fabric, something like that.
In fact, we make some proactive recommendations. So I like to call it the elastic fabric as well. We sort of hide that. But I mean, you're elastic at the node level, you scale up and scale down based on the throughput. We'll in fact recommend decommissioning an edge if we don't see traffic in that region. Right.
So Marquez had a pretty good question online, which was intra VPC traffic. So how small does this scale? I have services within the same VPC. Do I need to traverse the edge to have that intra VPC traffic filtered?
Great question, and I think you don't. The answer is no, and that is where the whole concept of how we slice the VPC when you're attaching it to the fabric itself, right? I know that Faraz is going to go through it, but just to quickly give you the answer, you can onboard an entire VPC. So when we attach these things to Prosimo Fabric, we use a term called a network. That network can be just a subnet from one VPC, or it can be an entire VPC, or it can be a collection of subnets from across VPCs, right? Now, let's assume that you want to do that micro-segmentation inside a VPC. What you do is, just to make it more real, what you do is you actually onboard one subnet as one network, the other subnet as other network, and then you deploy, because this is a special use case, we recommend deploying the Prosimo policy connectors inside that VPC. And we will configure the route table in such a way that if the traffic comes to Prosimo connector and we see that this traffic should not flow from this subnet to this subnet, we'll drop it there inside the VPC. The advantage that customers get is that you don't have to incur data egress charges from VPC to come to us.
Just in the interest of time, maybe we can. We can.
I think just one, not to put too fine a point on, but network. This network objects is sort of important.
Yeah, go ahead.